I am Morgan Freeman, and this is Tidal Forces. Have you ever wondered what caused low and high tides, or why moons or the rings of Saturn don't just fly into space? The answer lies in a phenomenon known as tidal forces. Ocean tides are the result of a gravitational force called tidal forces. You see, it's essentially the effect that celestial objects have on other celestial objects within their field. The Earth and the Moon, for example, have this effect where the Moon pulls on the Earth with its gravity, but the pull isn't equal everywhere. The side of Earth closest to the Moon experiences a stronger pull towards the Moon than the opposite side. Because of this tug, the Earth is being stretched out of its circular shape ever so slightly, like dough being stretched out. This stretching of the Earth causes tidal bulges, one on the side closest to the Moon and one on the opposite side.
Another way to think of this is if you take a snapshot of a point on Earth's surface, such as here, and a point in the center of the Earth, and compare how the Moon's gravity pulls the 2 points to find the tidal acceleration. So, relative to the center of the Earth, this point's tidal acceleration is radially inwards, or in other words, down. If we repeat this process at the other points of Earth's surface, it would look something like this. And this is precisely where the bulges come from. This diagram is exaggerated, of course, and the bulges created by the gravity of the Moon will only be about 2 meters at most.
And wherever the Moon orbits the Earth, the bulges will follow. So as the Moon circles Earth every day, the tides rise and fall along with it. Another interesting example of tidal forces is the rings of Saturn. Tidal forces are what causes the rocks and debris around Saturn to not fly into space, as the stronger gravitational forces of its 146 moons acting on Saturn cause a strong tidal force to keep them in orbit.
To better understand how tidal forces work, let's look at its history of discovery. Thousands of years ago, circa 330 BC, a Greek astronomer, Pytheas, first had the thought that the shifting tides were influenced by space somehow, mentioning this in his book On the Ocean. He concluded that there were 2 high tides per day, and that the tides were directly influenced by the phases of the Moon and which phase it was currently in. Later, Descartes, a philosopher, first theorized that the tides were a result of the Moon acting on the Earth in some way, but had no proof of this until hundreds of years later, when Sir Isaac Newton came up with an explanation for the shift in tides. Instead of me explaining it to you, how about I ask him to explain it himself? Oh, Great Spirit, are you with us? Great Spirit, please explain how you discovered tidal waves.
It all began upon a fair summer's morrow, as I didst repose upon a beach in London. There mine eyes took note of a curious pattern. Whenever the moon did wane from the heavens, the waters did rise anew, yet by nightfall the moon returned. The tides did lower, as though they did follow its celestial course. Thus I made careful record of this marvel and discerned a bulge formed upon the waters by the moon's gravitas. But then I quoth, what of the bulge on the far side? Aye, 'twas then I perceived it. The earth itself is drawn more mightily towards the moon than the distant ocean, leaving the waters behind, as it were. Galileo, that vainglorious fool, did scoff at such notations, dismissing them in his arrogance. Yet I, with mine insight, unraveled the mystery he would not. The existence of the tides is proof most profound that the universe is governed by laws immute and orderly, not by the whim of chance nor capricious gods. I thank thee, and I bid thee good day, fair listeners.
There are many possible applications we as humans could use tidal forces in. such as infinite renewable energy from the predictable currents of ocean tides, with places like Scotland in the Jayden project and South Korea's Sihwa Lake tidal power station taking advantage of this already. Tidal power and hydroelectricity is a much more reliable renewable energy source, unlike solar and wind. Another application of tidal forces is being able to inhabit other planets or celestial bodies in the future, as the movement of tidal forces and the gravitational impact it has can cause friction on a planet, which causes heat, which in turn causes water to stay liquid, potentially supporting life on that planet. And, of course, tidal forces cause satellites to stay stabilized in orbit of planets like Earth, or even much farther ones like Mars, allowing them to be probed. Here is a video that is an appropriate length and time, matches the phenomena fully, not too wordy or confusing to follow, and is interesting.
What causes tides? If you've ever spent a day at the beach, you've probably noticed that the ocean water is constantly moving. Waves cause the ocean to move all day long, and tides cause the ocean to rise and fall twice each day. The water's highest point is called high tide. The water's lowest point is called low tide. Plants, animals, and humans living near the ocean rely on this predictable rising and falling of the ocean each day. But what exactly causes high tides and low tides? The moon. That's right, the moon is the main cause of tides in Earth's oceans. The moon and Earth both have gravity, the force by which a planet or other body draws objects toward its center. The force of gravity keeps all of the planets in orbit around the sun, and Earth's gravity keeps the moon in orbit around Earth. The moon is a smaller object than Earth, so its force of gravity is weaker. But since the moon is so close, the pull of its gravity is still significant. As the moon's gravity pulls on Earth's water, the water bulges in the direction of the moon. This is due to something called the tidal force. Because of this tidal force, Earth's water on the side of the moon always wants to bulge out toward the moon. This bulge is what we call a high tide. As your part of Earth rotates into this bulge of water, you might experience a high tide. That explains the first high tide each day, but what explains the second high tide? This is where things get a little tricky. As we mentioned earlier, when the moon's gravity pulls on one side of Earth, it creates a tidal bulge toward the moon. But the tidal force actually affects the whole planet, not just one side of Earth. The total effect of the tidal force is that Earth experiences a squeeze, which causes the water to bulge on two sides. These two bulges explain why in one day there are two high tides. Earth's surface rotates through each of the bulges once a day.
A gravitational field is the force that large masses in space exert on other masses nearby. It's basically the circle of effectiveness around an object that gravity works in. The entire reason for tidal forces' existence is gravitational fields. The gravitational field of the moon is what creates deformations of Earth. Tidal forces also help us understand how gravitational fields work. It doesn't just pull, it stretches, compresses, and shapes objects throughout our universe. Scientists are still doing work to fully comprehend tidal forces. Several space exploration missions, such as the Europa Clipper that was launched this year, will discover information about gravity and tidal forces. There are also observatories that exist for the sole purpose of observing gravitational waves, such as the LIGO project. When massive objects exert tidal forces on each other, they disturb gravitational waves. So these observatories naturally record those as well. Simulations are being run by scientists using supercomputers to see and record how planets with different gravities will affect each other. Tidal forces are responsible for the internal heat that creates the volcanic activity on Io, one of Jupiter's moons, and the breakup of stars that get too close to black holes. Over millions of years, tidal forces are strong enough to literally tear apart moons or planets. Tides can be once or twice per day, depending on the location.
Here are 2 questions about this presentation. Who was the first person to discover the phenomena of tidal forces? The answer is Pytheas during his voyages. Question 2. Do you think that in the future, tidal forces will play a big role in contributing to the Earth's electricity? Personally, I think that yes, tidal forces are going to play a big role in the future of the Earth and its electricity, simply because tidal forces are much more easier to control and predict and rely on, unlike other renewable power solutions like wind and solar that rely on the weather and time of day. Thank you and good night. Morgan Freeman out.